Hi, this is Mr. Bissonette with another episode of Math in the Classroom. Today we are going to look at how to solve our quadratic functions for a certain value. We will start off by first explaining some of the different parts of a quadratic function, although it's a little bit different than some of our other functions, but we'll take a look at that and kind of explain that as we go. So here we go. We're looking at quadratic functions. Okay, so if you want a learning target, you could say something like, I will be able to solve quadratic functions for a particular value. I will be able to solve quadratic functions for a value. Okay, so now we'll start off by looking at what builds our quadratic equations and functions, what parts we know, and then go from there. So when we're starting off with a starting equation, we might look at something like f of x equals ax squared plus bx plus c. Now, the way that I help my students remember this is this one is the ABCs 0, 1, 2. So you go A, B, C, 0 x's, x to the first power, x to the second power. This goes back to another part that we were talking about in class, which is one of those things that as a math teacher, I do feel we have a bit of that confusion that comes is not knowing where the invisible stuff is. There is an invisible x that is right here, and that invisible x is to the 0th power. Why does that work? Well, anything to the 0th power is 1. 1 times c is still that c. X, the invisible power, is 1 that we don't state, and now you can see that a, b, c, 0, 1, 2. When we get into further mathematics, sometimes understanding that we can have that x hiding can help us out. But for now, we'll kind of take a look at it as just ax squared plus bx plus c. Now, the c is an easy part. We are going to call this our y-intercept. Okay. This is where it crosses our y-axis. So if we had something like plus 3 on the graph at 1, 2, 3, we're going to see that it would cross right there. Something else to understand about these is this a, what it does. If it is positive, well, I tell my students, if you're a positive person, do you smile or do you frown? You smile. And so our quadratic formula will open up if that is positive, and if it's negative, if you're a negative person, you're going to have that frown, and it's going to open down. Now, another thing to keep in mind as we are working with these quadratics, no matter how wide that quadratic is or how narrow, they are going to continuously get wider and wider and wider. That's an important part when we start talking about the domain of these functions. So keep that in mind. Another thing that we need to know is this point right here. It's either at the bottommost point or it's at the topmost point, but we're going to call that the vertex. Essentially, if you dive into calculus, this is where the slope of this is going to be at 0. This is where the instantaneous slope is going to switch from a negative slope to a positive or vice versa. Okay? When we look at these problems, the simplified version, this is one of those things that I kind of wrestled with a little bit in college. Sometimes we will use them to model specific things like ball flight, if we throw a ball, if we shoot a projectile, something like that. It creates this arc that we observe from our quadratics, and we can use that to model the information. The simplified way that they do that is this ends up becoming how gravity acts upon the object. So a lot of times we'll see negative 9.8 meters per second squared. A lot of times then this is going to be our initial velocity in a very complex derivation with also the angle of the projectile. And then this is going to be our height above ground. Again, that's kind of an oversimplified version of it. We'll see that, understand that's part of the truth, but we have to truly go into that calculus before we're able to get it all explained. So the easy stuff, our plus c is going to be our y-intercept. Our a is going to tell us whether or not we open up or open down. And that's kind of the basics of what we want to understand as far as building the equation currently. All right, if you need to write this down in your notes, feel free to pause the video and we'll move on to the next part. Okay, we'll go over a couple different functions. That way we can see some of the nuances of what's happening. We'll start off with the basic one and then we'll build it up a little bit from there. So let's say we start off with something like f of x equals negative 3x squared plus 2x plus 5, and we want to compute f of 4. So this is really diving into what that learning target is. I'll be able to solve quadratic functions. Quadratic functions, that is that part for a certain value. That is that part. All right, here we go. So first of all, we plug it in. So we'll have f of 4 equals negative 3 times 4 squared plus 2 times 4 plus 5. First step, plug it in. All right, now we hop right back into PEMDAS as always. You hear me say it a lot. Okay, it tells us what to do. This is the rule book of our mathematics. First thing it says is parentheses. Now again, we're asking ourselves, is there any math inside the parentheses? And if we take a look at it, the answer should be no. All right, exponents. There it is. We have our exponent squared. So we're going to do that part first. So we're going to have f of 4 equals negative 3. 4 squared, what does that mean? 4 times 4. So we're going to get 16 plus 2 times 4 plus 5. All right, now we have our exponents. Now we go on to our multiplying and dividing. And even though, keep this in mind, even though for the sake of remembering PEMDAS, that multiplying and dividing kind of happens at the same time, as well as that adding and subtracting. That can happen at the same time as well. But here we go. So it says multiply, so we're going to multiply this out. Negative 3 times 16, so we're going to have f of 4. It's going to equal negative 3 times 16. One thing you might think of is 3 times 15, so 15, 30, 45, and then you'll have 3 times that 1 to get 3 to get the 48. You can go the other direction with it, 3 times 6, and think 18, carry the 1. Negative 3 times the 1 is 3, plus the 1 is negative 48. Two different ways of thinking about that multiplication to be able to do it in your head. Maybe a little bit faster. 2 times 4, that's going to be 8 plus 5. Okay. There we go. We got the tough stuff done. We're on to adding and subtracting. Now, when we're looking at negative 48 plus 8, I ask myself, do I have more negatives or more positives? In this case, I have negative 48, so I have 48 negatives and I have 8 positives. I kind of think about each negative and each positive summing to 0. Here I got positive 8. If I took my negative 8, I would have negative 40 left, and my negative 8 and positive 8 would sum to 0. Again, just a different way of thinking about that might help you out. All right, negative 40 plus 5, we'll get negative, f of 4 is going to equal negative 35 for the final answer. Okay, that's a fairly simple one. Now, we'll take a look at this here, something like f of x equals negative x squared plus 3x minus 7. Okay, my students were struggling. What happens, Mr. B, when we have this negative in front? Well, the question that I ask them is, think about what happened over here. Mathematically, what are we doing with this negative 3 to the 16? And they all got that part right. They said, oh, you're multiplying, Mr. B. And so I said, what's this negative then doing to the x squared? And they did a great job. They got it. They go, ah, it's multiplying. Well, what is the invisible number that we're multiplying by? Negative 1. So we have to do the squared part and then reapply the negative. So if we're saying solve for, let's have a little bit of fun with this. Let's say f of negative 3. We plug this in, we'd have f of negative 3 equals negative, put your parentheses where that x is, negative 3 squared plus 3 times negative 3 minus 7. Okay, so we're going to do that negative 3 squared first. Negative 3 times negative 3 is going to be positive 9. And then we're thinking essentially that we're multiplying that positive 9 by that negative 1 on this next step. All right, negative 1 times that positive 9, so we're going to get f of negative 3 is going to equal negative 9, positive 3, it carries the sign in front, times negative 3 is going to be a negative 9 or minus 9. And we're going to get minus 7. I do this for my English speaking students. I also do this for my Spanish speaking students. This is one of those things that students mess up a bit. A minus and a negative are the exact same thing. In Spanish we say un negativo, un menos es igualmente. They are the same. Okay? It just tells us how we're going to work with it once we simplify those signs. Okay. So we have f of negative 3. Again, the way that I think of this is I have 9 negatives here, 9 negatives here. So if I count up all my negatives, I'm going to get negative 18. And then negative 18 minus 7. For our final answer, we're going to get f of negative 3 equals negative 25. All right, again, that's Mr. Bissonette with another episode of Math in the Classroom. Hopefully that helped you solve your quadratic functions for a particular value a little bit easier. Thank you.